Hello students, I am Vaishali Chaudhary, your chemistry educator for the day, and today I'll be teaching you the most important topic of electrochemistry, that is galvanic cell. So without wasting much time, let's understand what is a galvanic cell and how does it function. So what is a galvanic cell? Galvanic cell is a cell that converts chemical energy of a spontaneous redox reaction into electrical energy. Chemical energy of a redox reaction, spontaneous redox reaction into electrical energy. Now you must be wondering how chemical energy can convert into electrical energy, right? So first let's understand here that the input here is chemical energy, which is converting into electrical energy. That means the output here is electrical energy and the input here is chemical energy. Now ऐसे cells जिनमें chemical energy electrical energy में convert होती है, those cells are known as galvanic cell, and these are also known as electrochemical cells. So now, because there is a conversion of chemical energy into electrical energy, that means some chemical reaction must be taking place, because of which there is a production of electricity. So that chemical reaction, obviously, because chemical reaction is taking place, that means chemical reaction is taking place spontaneously, and that reaction should be redox reaction. So we can say that in galvanic cell, there is a production of electricity from a spontaneous chemical reaction. We can say that the chemical reaction should be spontaneous chemical reaction, or we can say spontaneous redox reaction. Now, because I am saying that spontaneous redox reaction, so you must have studied in your 11th standard that for a process to be spontaneous, or for a redox reaction to be spontaneous, or for a reaction to be spontaneous, the Gibbs ray energy of the system or the reaction should be negative. That is, delta G should be negative here if a process is taking place spontaneously. And what does spontaneous mean? It means that the reaction is taking place on its own, or the process is taking place on its own, or with some initiation. That process is known as spontaneous process. So in galvanic cells, there is a conversion of chemical energy into electrical energy. That chemical reaction should happen or should take place spontaneously. Then only there will be a production of electricity from that redox reaction, right? Because I have mentioned here that spontaneous redox reaction, that means obviously in this chemical reaction, oxidation and reduction must be taking place, right? Because of that, there will be a production of electricity. So now, for example, you must have seen the cells which are present in your TV remote control. There also there is a conversion of chemical energy into electrical energy. So such cells where there is a conversion of chemical energy, that means some chemical reaction is taking place, and because of that there is a production of electricity, those cells are known as galvanic cell or electrochemical cell, right? So now let's understand the working of galvanic cells. How does galvanic cell functions? So for that, I will be taking the example of a Daniell cell where the zinc and copper electrodes are involved. So now I'll be explaining you the working of galvanic cell. Galvanic cell. So for explaining the working of galvanic cell, I'll take the example of zinc and copper electrode, and the cells in which zinc and copper electrodes are involved. Such cells are known as Daniell cell. Daniell cell. So now, see, what is the first thing that is coming to your mind now? Okay, now you have understood that because there is a production of chemical energy into electrical energy, those cells are known as galvanic cell. Now the thing that is coming to your mind now is that how we'll prepare, or how such cells can be prepared. What is the material that we'll use in such cells? This thing is coming to your mind, right? So now let's understand this. So Daniell, see, what is a Daniell cell? Daniell cell is a galvanic cell, but it is called Daniell cell when the zinc and copper electrodes are involved. Zinc and copper electrodes are involved. Copper electrodes are involved. So let's understand this, that how we'll prepare this cell. So for this, you have to take two beakers. One beaker containing 1 molar solution of zinc sulfate, that is ZnSO4, and another beaker containing 1 molar solution of copper sulfate. Now you have taken two beakers, one containing 1 molar solution of zinc sulfate and another containing 1 molar solution of copper sulfate, right? Now these see, zinc sulfate and copper sulfate are the electrolytes, right? And electrolytes are the substances which can dissociate into ions after going into the aqueous solution. So this one beaker is having 1 molar ZnSO4, zinc sulfate. In this solution, there is a zinc electrode. Zinc is a metal. Zinc electrode is dipped. This is the zinc electrode. Zinc electrode. And in copper sulfate solution, copper electrode is dipped. This is your copper electrode. Now, these two are the metal electrodes. Now, these two electrodes are connected to each other via ammeter through an insulated wire through which electricity can flow. Now you understand that because in galvanic cells there is a production of chemical energy. There is a production of electrical energy from chemical energy. So that means some current must be flowing. Now how you will be able to check that whether current is flowing or not? So that you can check with the help of ammeter, right? Now the circuit is completed externally, because these two metal electrodes are connected to each other via through a wire, and in that ammeter is also put, just to know whether the current is flowing or not. Now these two electrolytic solutions, that is zinc sulfate and copper sulfate electrolytic solutions, these two are connected to each other through an inverted U-tube, and that inverted U-tube is known as salt bridge. Salt bridge. Now, what is salt bridge? Salt bridge is an inverted U-tube which contains semi-solid solution of inert electrolytes such as KCl, K2SO4, ammonium nitrate, NH4NO3. Semi-solid solution of such electrolytes. Now because I am saying that semi-solid solution, that means you will take these electrolytes. These are the inert electrolytes. Why I'm mentioning inert electrolytes, that I will explain you later when I'll explain you the function of salt bridge. So for now, you have to keep in mind that the circuit, these two solutions, that is the zinc sulfate solution and the copper sulfate solutions, these two are connected with each other through an inverted U-tube. In which inert electrolyte is filled, and this inverted U-tube is called salt bridge, right? I'll explain you the function and everything at the later step, right? Now, once the circuit is completed, now what we have done in this, in making this cell, we have taken one beaker containing 1 molar zinc sulfate solution and in which zinc electrode is dipped. Another beaker containing 1 molar copper sulfate solution and in which copper electrode is dipped. Now these two electrodes are connected to each other via wire, and in which ammeter is also put, just to check whether the current is flowing or not. That means the circuit is completed externally, and internally we have completed this circuit or the cell in which the ZnSO4 electrolytic solution and the copper sulfate electrolytic solution, these two are connected to each other through a salt bridge, which is an inverted U-tube and which contains semi-solid solution of inert electrolytes, that is potassium chloride and ammonium nitrate. And we can take other electrolytic solutions, inert electrolytic solutions also. Now, when the circuit is complete, what will happen? Now, following changes were observed. Now, what are these observations? Once the circuit is completed, or the cell, this whole cell is completed, following changes were observed. Number one was that, because you can see here that zinc electrode is dipped in ZnSO4 solution and copper electrode is dipped in copper sulfate solution. Now, it was observed that the first point which was observed was that the zinc electrode is losing its weight. Number one, was that zinc electrode is losing its weight. Its weight. And the second point was that zinc electrode was losing its weight and the concentration of Zn plus 2 ions in the solution. See, this is your ZnSO4 solution, which is taken in the beaker. Now, when you dipped this zinc electrolyte into ZnSO4 solution and copper into copper sulfate solution and completed the circuit, then it was observed that the concentration of Zn plus 2 ions, I'm mentioning here, that the concentration of Zn plus 2 ions in the solution was increasing. Zn plus 2 ions की concentration increase हो रही है solution में. So I'm writing here that the concentration of Zn plus 2 ions, concentration of Zn plus 2 ions in the solution was increasing. Right? Third point was that it was observed in the left beaker in which zinc was dipped in ZnSO4 solution. In the right side beaker, in which copper electrode was dipped in copper sulfate solution, what was happening? That the thickness of the copper electrode was increasing. I'm mentioning here that the thickness of copper electrode was increasing. Thickness of the copper electrode was increasing. Also, the concentration of copper plus 2 ions in the solution. I'm writing here, the concentration of copper plus 2 ions in the solution was decreasing. So these observations must be related to something. No? Something must be happening here. So I'm writing here that the concentration of copper plus 2 ions in the solution was decreasing. Concentration copper plus 2 ions की solution में decrease हो रही थी. Also, the last point which was observed was that there was a flow of electric current. That means what I'm saying here is that the electrons were flowing from zinc electrode to the copper electrode. Electrons were flowing from the zinc electrode to the copper electrode, and obviously because current flows in the opposite direction. So current was flowing from copper electrode to the zinc electrode, which was observed with the help of ammeter. So there was a flow of current. Flow of current was observed. Flow of current was observed from copper electrode to the zinc electrode. Copper electrode to the zinc electrode. Now, these observations, obviously, if something is happening, the zinc electrode was losing its weight and the concentration of zinc plus 2 ions in the solution was increasing. The thickness of copper electrode was increasing and the concentration of copper plus 2 ions in the solution was decreasing. And last point was that there was a flow of current from copper electrode to the zinc electrode. Then these are indicating. Now, these observations can be explained. Now, because starting from the first point, these observations must have some conclusions, right? So the first point is saying that the zinc electrode was losing its weight. Zinc electrode अपनी weight को lose कर रहा था. That means obviously this zinc electrode is made of atoms, right? Zinc electrode is made of atoms, and obviously because the concentration of Zn plus 2 ions in the solution is increasing, that means these atoms are changing into ions after losing electrons. This is what we can conclude from here. Because zinc electrode was losing its weight and the concentration of zinc plus 2 ions in the solution was increasing, this means that these zinc atoms must be losing electrons in order to convert into Zn plus 2 ions. Then only we can say that there is an increase in concentration of Zn plus 2 ions. Yes. So yes, we can conclude, we can explain these observations. So I am writing here, what are the conclusions? These observations can be concluded in a way that because the concentration of Zn plus 2 ions in the solution was increasing and the thickness was decreasing. That means the zinc atoms, that zinc electrode is made up of atoms, and these atoms must be losing electrons. That is, they are converting into Zn plus 2 ions after losing electrons, right? So now, because zinc is losing electron, that is, zinc is losing 2 electrons, and then only it is converting to Zn plus 2 ions. So here we can say that loss of electron is called oxidation. So we can say that at zinc electrode, there is oxidation is taking place. So here we can say that oxidation is taking place at zinc electrode. So I'll tell you again the point that because the concentration of Zn plus 2 ions in the solution is increasing, that means that zinc atoms are oxidizing, and oxidation means loss of electrons. So here I have written that zinc is losing electrons and is converting to Zn plus 2 ions. Now, coming to the copper electrode, because we have written here, please look at this point, because we have written here that it was observed that the thickness of copper electrode was increasing. If the thickness of copper electrode was increasing, this means that copper ions which are present in the solution, in the electrolyte, these are the copper ions, because this copper sulfate has copper plus 2 ions and SO4 minus 2 ions. Because thickness of copper electrode is increasing, that means these copper ions must be gaining electrons and they are depositing on the copper electrode. Right now, where are these electrons coming that the copper ions are gaining? Copper ions which are present here, they must be gaining electrons and then they are depositing on the copper electrode. So here we can say that reduction is taking place. Now, from where these electrons are coming that the copper ions are gaining? So here, these because zinc has lost electron. Please understand it very carefully, because zinc has lost electrons. So these electrons, I'll use different color. Yes, because zinc is losing electron and is converting into Zn plus 2 ions. So these electrons are now traveling through this wire towards the copper electrode. And copper plus 2 ions from the electrolyte, they must be gaining these electrons, and after that they'll be depositing on this copper electrode, right? So I can write here that copper plus 2 ions in the electrolyte are gaining the electrons and then they are depositing on the electrode as a copper atom. That is why the thickness of copper electrode is increasing. We can say that, right? So, and this, because what is happening here in the right compartment where the copper electrode is dipped into copper sulfate solution, what is happening here? Here copper plus 2 ions are gaining electrons and then depositing on the copper electrodes, and the gain of electrons is known as what? Gain of electrons is known as reduction. So gain of electrons is known as reduction. So in this right compartment, in the right beaker, what is happening? Reduction is taking place. So we can summarize the picture again, that zinc is losing electrons. In the left beaker, what is happening? Zinc is losing electrons and is converting into Zn plus 2 ions after losing the electrons. Now these electrons are traveling through the wire, through this wire towards the copper electrode, where this copper electrode is dipped into copper sulfate, where the copper plus 2 ions are gaining those electrons and depositing on copper electrode. That is why the thickness of copper electrode is increasing. So we can write the reaction here also, that copper plus 2 ions are gaining electrons, 2 electrons, and are depositing on copper. This is how the thickness of, similarly, several other zinc atoms must be losing electrons. Then Zn plus 2 ions, obviously the concentration of Zn plus 2 ions in the solution will increase. And copper plus 2 ions are gaining electrons. So the concentration of copper plus 2 ions obviously will decrease. Why it will decrease? Because you know that in copper sulfate, equal number of Cu plus 2 and SO4 minus 2 ions are present. Copper plus 2 and sulfate ions are present. Now when, obviously, because then copper ions are gaining electrons, then they are depositing on copper. Now, obviously, there will be more negative charge in the solution. No? So that is why copper plus 2 ions concentration will decrease in the solution. I hope I'm clear to you. So yes, because oxidation is taking place at the zinc electrode and reduction is taking place at the copper electrode, And we all are aware, we all have studied this in redox reaction class 11th, that oxidation takes place at what? Which electrode? Anode or cathode? Anode. At anode, oxidation takes place. So at anode, oxidation takes place, and hence this zinc electrode is known as anode here. And reduction takes place at which electrode? Obviously, we are left with now cathode. So cathode reduction is taking place. So this copper electrode is known as, here in this cell, is called cathode. So I can mention here now that this copper electrode is here, is acting as a cathode, and this zinc electrode here is acting as a anode. I hope you will remember this. And now let's understand which charge this electrode will be having, and which charge this cathode will be having. So now, because, please listen to me very carefully, because zinc atoms are losing electrons and are converting into Zn+2 ions. Now this electrode will be left with electrons. Hence this electrode is negatively charged. And because these electrons are traveling through the wire and traveling towards this copper electrode, because copper+2 ions are gaining electrons, and after that they are depositing on this cathode. So this electrode will be positively charged. So please remember that in case of electrochemical cell or the galvanic cell, anode is negatively charged and cathode is positively charged. So I'm writing here, because it is reverse in case of electrolytic cells. So yes, here we can say that anode is negatively charged and cathode is positively charged. I hope you have understood this concept. So let's move. In case of what I've explained you just now, in case of electrochemical cell, this anode is negatively charged and cathode is positively charged, right? And here in case of Daniell cell, which electrode is acting as an anode? Zinc electrode, because oxidation is taking place here. And which electrode is acting as a cathode? Copper electrode, because reduction is taking place here, right? So now we can write here. Also, one more important thing is that this zinc electrode, which is dipped in ZnSO4 solution, this is 1/2 cell. Zinc electrode is dipped in ZnSO4 solution, this is 1/2 cell. And the copper electrode is dipped into copper sulfate solution, this is another 1/2 cell. Now these two are different 1/2 cell. Now because oxidation is taking place on zinc electrode, so this cell is known as oxidation 1/2 cell. And because reduction is taking place on copper electrode, so this cell is known as reduction 1/2 cell. So I'm writing here that because copper on zinc electrode, what is taking place? On copper electrode, oxidation is taking place. Oxidation is taking place. And this 1/2 cell, this zinc dipped in ZnSO4 solution. Zinc electrode is dipped in ZnSO4 solution. This is oxidation 1/2 cell. Oxidation 1/2 cell. And copper electrode. And if I talk about copper electrode, the compartment where the copper electrode is dipped into copper sulfate solution. Copper sulfate solution. So here reduction is taking place. So this 1/2 cell is called reduction 1/2 cell. Reduction 1/2 cell. And together, oxidation and reduction, because oxidation and reduction cannot take place independently. So these together are making the complete cell. That is oxidation 1/2 cell and reduction 1/2 cell together are making the complete cell. So now if I want to write the complete reaction, because I've written here that at anode, this is the reaction which is taking place at anode. And this is the reaction which is taking place at cathode. Now, if I'll combine these two, what would be the overall reaction? Two electrons will cancel out, and the overall reaction would be zinc plus copper plus 2 ions will give Zn plus 2 ions plus copper. This is the reaction for the complete cell. Now, the most important, I haven't discussed the function of salt bridge yet. Let's understand the function of salt bridge now. Now, because you have seen that what is happening, that in case of oxidation half cell, what is happening, that zinc electrode is losing its electron and Zn plus 2 ions are going into the solution. So there will be accumulation of positive charge in the electrolytic solution. And because this anode is negatively charged, so there will be a negative charge on the electrode. Negative charge on the electrode. And if I talk about this reduction half cell, what is happening in reduction half cell? On the copper electrode is positively charged. And because copper ions are depositing on the copper electrode after gaining electrons, there will be more negative charge in the electrolytic solution. Now, let's understand the function of salt bridge. Now, you have seen that zinc atom is losing electrons and is converting into Zn plus 2 ions. Now, once this Zn plus 2 ion is coming into the electrolytic solution from this electrode, Zn plus 2 ion. Now, when the next zinc atom will come, obviously, when the next zinc atom will come after oxidizing, this next zinc atom will get the repulsion from the positive charge which is already present in the solution. Earlier it was neutral. Why? Because equal number of Zn plus 2 and SO4 minus 2 ions were present. But now, once this zinc atom has oxidized, now what is happening? We have more positive charge in the solution. Because we have more positive charge in the solution, that means when the next zinc atom will come, it will get repulsion from the already accumulated positive charge. So in that case, and obviously our cell will stop working, because if zinc atom will not oxidize, there will be no flow of electric current. And electrons will not travel from zinc electrode to the cathode, this copper electrode. So our cell will stop working. So for that, here comes the function of salt bridge. Now, salt bridge, what is the function of salt bridge? Salt bridge maintains electrical neutrality. Salt bridge क्या करता है? Now, जैसे ही आपके solution में Zn plus 2 ion आया, तो salt bridge क्या करेगा? आपका यहाँ पे एक negative charge migrate कर देगा. For example, there are two positive charges in the electrolytic solution. So salt bridge, let's suppose we have taken salt bridge में हमने KCl लिया है. So KCl in we have K positive ion and Cl negative ions. So now, what will salt bridge do? Salt bridge का ये काम है that it will migrate the negative ions towards this electrolytic solution. Because आपके solution में extra positive charge था, तो दो Cl negative इधर migrate कर देगा, so that आपका जो charge है वो neutral हो जाए. I hope you are getting my point, right? And because there is accumulation of negative charge in the cathodic compartment, this reduction half cell. So here what is happening? Negative charge is accumulating. So salt bridge क्या करेगा? Salt bridge will migrate this positive charge towards this reduction half cell. And because it will migrate the required number of this positive charge towards this half cell, so it will neutralize the charge which is accumulating, right? So salt bridge का काम होता है that it maintains electrical neutrality. Also, it completes the circuit internally. So I hope you have got my point. I'm explaining again that salt bridge हमने क्या लिया था? We have taken let's suppose we have taken KCl. So because when zinc atom will oxidize and will convert into Zn plus 2 ions, there will be extra positive charge in the solution. So what salt bridge will do? Salt bridge will migrate the required negative ion towards this electrolytic solution, so that then this extra positive charge will get neutralized. And towards this cathode or cathodic solution or this electrolyte, in this electrolyte, that is the copper sulfate electrolyte, there are more positive charges. So salt bridge what will do? Because there are positive charges, so salt bridge will migrate required negative ions towards this electrolytic solution, so that the charge will get neutralized. Right? So what is the function of salt bridge? First, it maintains electrical neutrality, and second, salt bridge, it maintains electrical neutrality And second is that it completes the circuit internally, electrical neutrality. And secondly, it completes the cell internally, right? And as I explained you that what is a salt bridge, this is the function. This is the function of salt bridge, what salt bridge is doing. And I've explained you in the very beginning also that what is a salt bridge. Salt bridge is inverted U tube. Is inverted. You must have seen that I've drawn this inverted U tube. So the first point is that it is inverted U tube, U-shaped tube with A, and secondly, it contains inert electrolyte. Contains inert electrolyte such as KCl, ammonium nitrate, etc. Right? And semi-solid solution of such electrolyte, in electrolytes the semi-solid solution we take in agar-agar or jelly-like substance. Semi-solid solution of such electrolytes is taken in agar-agar or jelly-like substance. Or jelly-like substance. So I hope you understood what is a salt bridge. Also, the ends of this U tube, the ends of this U tube are plugged with some porous material like wool or cotton. The ends, so that the electrolyte cannot go directly. So the ends are also plugged with some porous material. Also plugged with some porous material like cotton or wool. So this was about salt bridge, and function I have explained you. Also, let's understand the representation of the cell, that how we will represent this electrochemical cell. Representation of electrochemical cell. Electrochemical cell. So how you will represent this electrochemical cell? First, we'll take, see, you what I've explained you, we have kept the anode, this anode dipped into electrolytic solution. So this anode is written on the left hand side, right? Anode was of zinc. Anode आपका किसका था? Zinc था. That was solid. And electrolyte was aqueous. So whenever there is a phase difference, we represent it by a slash, right? Then it was dipped into electrolytic solution, which was ZnSO4. So ZnSO4, aqueous. So anode slash, why we have put slash here? Because there is a phase difference. Your zinc electrode was solid and your the solution that was in aqueous form. So anode dipped into anodic solution. Anodic solution. This is one half cell. That is your oxidation half cell. Now, बीच में क्या था हमारा? Salt bridge था. Salt bridge is represented by double vertical line. And then you have to write this cathodic solution. Cathodic solution. And then cathodic solution was aqueous and your electrode is solid. So we'll represent it by a slash. Cathodic solution and then cathode, which was your solid. So here we'll write the salt bridge, and then cathodic solution was copper sulfate, which was aqueous. And then cathode is your copper, which was solid. Sometimes the concentrations are also written in the bracket. So this was about the representation of the electrochemical cell. I hope you understood the concept very clearly. Thank you.